Hi, good afternoon, everybody. So, before I start, I want to introduce myself. I'm an IT professional, passed out from NIT Durgapur almost 18 years back, and after that, I'm serving IT industry. But due to my passion for mathematics, I kept myself attached to this also and coached JE students on mathematics. But right now, I just changed the concept a little bit, and I wanted to go through all the chapters, theoretical and typical problems, chapter by chapter sequentially, like as we do in our classes, regular classes. So I hope you will all get benefited with this, and your requirement for separate tuition should be a little bit reduced. Your dependency should be reduced a little bit. With that hope, I will start. So today I will start with few typical problems on indices. So before that, I will just summarize what we have learned yesterday. So basically the laws a to the power m into a to the power n equal to a to the power m plus n, a to the power m divided by a to the power n equal to a to the power m minus n, then a to the power m whole n equal to a to the power mn, then a to the power m divided by b to the power n equals to a by b to the power m, a to the power m into b to the power m equal to a b to the power m. Again, if a to the power n equal to b to the power n, so a equals to b when m not equals to 0. Otherwise, m equals to 0. a b should not be equal to 0. With that, I want to add something on indices, like what is the value of 0 to the power 0. I forgot to discuss this in yesterday. What is the value of this? Actually, this is indeterminate or undefined, and why it is, so I will just discuss. So 0 to the power 0, so I will just write this to the power as, actually let me start from here, 0 to the power m minus m. So from this, I can write m minus m, this one, write it as 0 to the power m by 0 to the power n. Now we know 0 to the power m means multiplying 0 m times, result is 0. Same here, so this is undefined, or we can say indeterminate. So I will erase this and move next to the real typical problems. So first problem, 0.243 3 to the power 0.2 into 10 to the power 0.6. So you should concentrate on what will be the tricks, means why am I doing this, because every problem can be solved in many ways, but why am I doing a particular way, just understand that one, so it will help. First, I will keep it same and make this power or this exponent same as this one. So for that I can write it as this one. So see, 0.6 is broke into two factors, 3 into 0.2. So now I can write a to the power m into b to the power m equal to ab to the power m. So if I multiply, it becomes 2, 4, 3 to the power 0.2 means 1 by 5. Now this one, let's factorize. Let's see what do we get. So 3 to the power 5 to the power 1 by 5, so equal to 3. Okay. Now to the next problem. 20 to the power x to the minus x equal to 1 by 7. So what is the value of 20 to the power 3x equal to what? So we know a to the power minus x equal to 1 by a to the power x. This implies 20 to the power x equal to 7. Now I will write this one as a to the power mn equal to a to the power n whole m or a to the power m whole n. Anyway we can write it. So I will write it as 20 to the power x whole cube, as I know the value of 20 to the power x. I will not think to write it as 20 cube whole x. I will write it as this. So this becomes 7 cube. Okay. So 7 into 49. This is the answer. Okay. Let's move to next. Slowly we will move to little bit tougher problems. I have 4 numbers. You have to put it in ascending order. 2 to the power 60, 3 to the power 48, 4 to the power 36, and 5 to the power 24. So we cannot compare directly because everywhere base is different and the exponent of the power is different. So either we have to calculate it, that is not logical at all. So another way is either you make base equal or the power equal, something so that you can compare. So what I will do, I will make power equal here. How can I do that? HCF of all this is 12. Okay, so I will break the power as a multiple of 12. So I will make it 12 into 5, 12 into 4, 12 into 3, 12 into 2. Now see, I can write a to the power mn as a to the power n whole n. Here also this, this. Now this is a small thing we can calculate, no problem. 2 to the power 532, 3 to the power 481, 4 cube, it is 64, this is 25. See, if the power is same, now I can compare this base value. So no problem. So first one, the smallest one is this one, 5 to the power 24. I will not write. So smallest one is 5 to the power 24. And then next one is 2 to the power 60. Third one 4 to the power 36. Then 3 to the power 48. Okay. Okay, so we will move to next problem. Okay. What is the value of this one? Root over of x. Please note that some of you may find it a little bit slower, but keep in mind that these are the regular classes that I am doing. So in that I have to keep in mind that some needs a little bit slower pace and some need a little bit higher pace. So depending on that, I'm trying to means I'm just considering both of the audiences in that way, trying to go, but I will see if I get the feedback that I need to go a little bit faster, I will move that way. What is the value of this one? So I will consider it as y. Now I will square it. Why I am squaring it? Because after squaring the outer x comes out and whatever is left out inside, this is actually again y. So y square becomes xy. So y into y minus x equals to 0. So either y equal to 0, that is not possible, because I am assuming x is a positive number, any number, it can be 2 or 3 something. So when we take root, it will be a positive thing. It cannot be negative, or it cannot be 0 at least. So I will not consider this one. So y minus x 0, so y equal to x. So what we assumed y, this is actually x. So root over of x, root over x in this way to the power into infinity, it becomes x. Now a to the power 1 by 3, b to the power 1 by 3, c to the 1 by 3, which is 0. We have to prove that a plus b plus c their whole cube equal to this. So from a to the power, just consider a. So we need to reach a from a to their 1 by 3rd. So somewhere we need to do a cube. So when we want to do a cube of this one, that means total cube. Otherwise you cannot separately cube this one. But when you do the whole cube of 3, it becomes a little bit complicated. So keep the two terms in one side and the third one on the other side. Now I am doing one step jump. It becomes this. Now a cube is a, b cube is b, 3ab into a plus b is minus c to the power 1 by 3. This is minus. Now I take that c this side this is actually minus, so minus 3, then ABC to the power half. I move that to the other side, it becomes plus this one. Now I make the whole cube of this, so it becomes 27 ABC. Proved. Okay. Another problem is x to the power a, y to the power b, x, y to the power c. So what is the relation between this, a, b, c? We need to find out that. So assume this equal to this equal to this equal to k, left. This is a constant. So when this x to the power equal to p, k, that means x equal to this. Y to the power b equal to k means y equal to k to the power 1 by b. Xy to the power c equal to k, that means this. Now multiply x into y gives us x. So that means x into y, that gives us this. This is the required relation. Okay. Now see, x to the power y equal to y to the power x. You have to show x by y to the power x by y equals to x to the power x by y minus 1. So let's see. We'll start from here, left hand side. We can write x to the power x by y. Now see, here everything is x to the power. While solving this, how will you solve? You have to think that way. So I am thinking that right hand side does not have the denominator as y. So I will think from that way, and then I think that in that case I have to replace y with x. So I will proceed on that way. So I will write it as y to the power x to the 1 by y. Okay. So what it becomes, y to the power x as it is given. So y to the power x is x to the power y, then into this. So this is x. So see, the result is this, and this is proved. So it is just the way that you have to find the clue. Clue is denominator need to be replaced with x. That is the clue, and you will reach the solution. Another problem, 64 to the power x equal to 48 to the power y equal to 36 to the power z. It is given. Now you have to find the relation between x, y and z. So let it k. So now you know this. 64 to the power x equal to k, that means 64 equal to this. It is same, till now it is same as we did in one of the earlier problems. Now see, we have these three numbers, so we have to form an equation using three numbers. How will you do that? This is 8 square. This is 8 into 6. This is 6 square. That means 8 square into 36 square, that is actually what it is. 8 into 6 square, that means 48 square. So now 64 is this, 36 is this, 48 is k to the power 1 by y whole square is this. So it readily follows that this. So this is the required relation. This is simple. So the main thing is the concept. Then as you practice more and more, you will be able to solve these things comfortably, because indices is a very easy chapter. Anyway, so for today we'll finish this till this, and I hope you learned something, because that is the ultimate aim. So with that, thank you all. Thanks.